Hello everybody, welcome to our second lecture in the Artificial Intelligence and Big Data course. I'm Professor Abolghasem from Sadeghi University. In this lecture, we are embarking on the fascinating and wonderful journey exploring our intersection of tangible reality and digital realm. I will explain why I am going to touch the cyber world and the reality related to this course. We will examine how we are leveraging technology to solve complex real-world problems. Why? Because AI and big data we are going to teach is something which help us to solve our real world problem, because in the real world we have many sort of problem. So that's why we need some computer, not only computer but also very intelligent computer. And why this understanding is crucial for our journey in AI and big data, I'm going to touch today. As we begin this course, it is important to consider why human turns to computer and artificial intelligence in the first place. We'll trace this journey from early days of computing to the current era of AI and big data, understanding the motivations and innovation that brought us here. Okay, great. Let's go for next slide and to see what I have today for you. So before I go detail, let's outline our agenda for today. Introduction, key concept. I'll talk about some key fundamental concept which is helpful for our course. The physical world characteristic and challenges. We need to really understand what is the physical world, and then dive to cyber worlds and its emergence and importance. Bridging physical and cyber world, that would be very important, then I will touch. To help and support my teaching, I decided to touch a little bit about the philosophical perspective on multiple worlds and translating real world problem into the cyberspace, what I have in my mind. At the end of this slide, I will consider the role of data and algorithm in digital solution. Please remember that data and algorithm together make a program, and this program is the issue here that we have in the real world. So usually real world problem, if I show with different color, that would be like this. The problem means issue which we have. Let's say consider we have a physical world and we have a cyber world. So we live in the physical world. We need to bring our, so in the physical world, we have our task. Let's say problems, any issue. For instance, you would like to manage the traffic problem in the roads. That is problem. Then we need to make some equivalent program in this cyber world. So problem in the physical world convert to the program in the cyber world. So I will go very nicely use this sort of basic concept before start. AI, big data, simply you can find everywhere, many book, many YouTube channel. So what I am trying to help to teach you something which you cannot easily find everywhere. So this is my lectures. And before we do some hands-on practice, I'll try to let you learn something and try to use some conceptual based journey that will take us from the concrete reality we experience daily to the abstract digital space that, revolutionizing the problem solving across the industries. So I'll try by the end of this lecture, and you have a solid foundation for understanding transformative power of the AI and big data. As you can see here, the reason I'm explaining here more, because this is the beginning of the lecture, you should be familiar why I'm touching like this concept. So this is the data and algorithm. So this is algorithm. AI is here, and big data concept is here. So if I simply explain that, you can see why AI and big data is important. You see, because many issue, traffic, like health management issue, like corona case, many issue happen in the real world, but we cannot use without power of the new technology. So we need to bring that problem to the cyber world. Then we make a program. So one program is including two parts: data structure and data, and algorithm. So any program in the cyber world, in the computer world, in the digital world, different name. For example, this has a physical world, a real world, reality. This is what we live. And in the another environment, is a computer science. We call it cyber world, digital world, computer world. So when we make a program, so two parts: big data and AI. So that's why this class is very important. For data part, many concept history we will touch, and algorithm part. AI is a very intelligent and advanced algorithm. We will talk about the very old and traditional algorithm, then come to the AI, and then do some hands-on practice to understand. But before we go to that step, I'm trying to, let you know, understand some basic, so which is important and helpful for our lectures. Okay. So in this presentation, we will focusing especially on the modeling aspect. Modeling is the crucial in translating real world or physical world into digital solution, forming the foundation of how we use AI and big data to tackle complex challenges. But why is modeling so important? Remember, modeling here, conversion from physical world to cyber world. Why modeling is important? Imagine trying to solve complex problems like climate change without a model. Where would you start? Model allows us to simply complex system focus on key variable and make prediction. In the context of AI and big data, models are bridge between the raw data and actionable insights. So what happened? AI and big data is the concept of this class. Model is a bridge between the raw data and actionable insight. So AI, I will teach in the next lecture more about this concept. So how AI help us take raw data and then change it to the actionable insight. As we progress through this course, you will see how different type of models, from a statistical model to the neural networks, and which is play a crucial role in the AI application. Let's see this page. Although is fancy and simple, but what I try to show in these figures, this figure is the core of today's discussion, revolve around the transformation of the real world, specifically how we are modeling. If I show you by maybe the red color, so if you see this borderline here is something, this part looks like physical, this part cyber world. So from every physical part you have a equal cyber object. So many information here in the physical world come to the number and big data and some algorithm which manage those big data. So from here to here, we will use some transformation and modeling technique. And we try to talk how we are modeling the physical world to the cyber realm. This transformation is at the heart of the modern problem-solving technique, allowing us to leverage computational power in ways previously unimaginable. So, this is the point. Consider evolution of the weather forecasting. In the past, meteorologists rely on physical observation. Just do some observation in the physical world. Physically try to observe and rely on basic model. But today we use supercomputer here to progress vast amount of the data from satellite, from weather station and historical records to create highly accurate forecast. This is the prime example how we are, transforming a physical world problem to the, cyber solution. So this is a very important concept that we are going today, touch during today's lectures. Okay. Every pictures and figures and text which I put in this exercise, there is a, concept behind that one. So please pay attention to every element. I spent too much time and efforts to, transfer some concept to you to learn more about what I have in my mind. And I'm trying to, teach something which easily you cannot find everywhere. So please pay attention to the value of my slide. Many times I edited my slide, changed the text. So I was thinking, what should I talk to help a student deeply understand, concept of the AI and big data. Okay. Well, a fundamental question we face is how we do accurately model object from our physical world. This is our physical world. So then we have a many objects here in the physical world. I divided too many parts. So how we really precisely can model from the real world in the digital space. This challenge involves translating complexity, variability and interconnectedness of the real world object into the data and algorithm. Remember, data algorithm in the computer science, inside the computers which we can process. Let's consider a practical example. Let me give you one practical example. Imagine someone wants to travel from A to B. For instance, let's say you want to travel from, suppose here one place in the earth, you want to travel to the another place, so in the earth, in the physical world. So consider in a one big city, 2 points you want to travel. In the physical world, this journey involves navigating through a street, dealing with the traffic, avoiding obstacles, and making decisions based on the real world conditions. To model this is a cyber world, we need to, several things we need to consider. Let's say like we need to create digital map of the all street and roads, because in finding the going from A to B in the physical world is very challenging, right? So we want to bring that issue from the real world to the cyber world and create digital map of street and road. Step 1. Step 2, we need to input real-time traffic data from sensor and camera. Step 3, we need to digitize information about the building, trees, and other landscape. We need to bring to the some cyber world divided several information. You see here satellite map, computing, everything. We need to digitize information about the building, trees, and other landscape. In the step 4, we need to create algorithm to process this data and find optimal route. Wow, very nice. So again, if I make something again, so in the real world, we want go to the cyber board. We want go from a node to B. So see, when we want to, if in the physical world, if we don't use any new technology, computer, if traditionally, computer came around 100 years back, roughly 100, 200 something. Before, many people wants to go A and B. Some people go this way. Next time, understand, oh, your friend said, why don't you go that way? Is closer. And your family said, okay, for example, in the weekend, it is better go from this way. But you need to many times go and back. And even if you try, you cannot say you can go the best way in the physical world. It is, again, dependent situation. You are going to go from A to B in the morning, early morning, in the weekend, at night, in the noontime, in a holiday, everything can be changed. So then finally, you will decide, bring everything to the cyber world. Every time you click, for example, in Google Map, Kakao Map, A, B, depend on day, traffic, give you, best. Same application, if you choose in holiday, same point A and B, if this environment is based on the intelligent, software, and you have consider a lot of data, big data, the huge weather data, then maybe choose you another intelligently. So this is the main concept which I'm trying to explain situation. By bridging all this information in the cyber world, we can then use powerful algorithm to calculate the best route, considering factors that would be too complex for humans to process quickly here. This is how application like Google Map work, demonstrating, power of the bridge, the physical and cyber world. Okay, so this would be very helpful if you really think about like this, and that would be very interesting. Okay, let's go and consider why we turn computer in the first place. Turn on computer in the first place. Why we need computers? So I put something here, but I would like to explain more than a slide. Let's consider the reason why we need a computer. First reason, increasing complexity. Our world is becoming increasingly complex, even more complex. For example, like 100 years ago, the roads didn't have such a big traffic. And we don't know 100 years later what would be happen. So we need something to help us. From climate system to the global economic, the problems we face often involve numerous increasing variables that are difficult for human mind to process simultaneously. For instance, predicting the spread of the pandemic involves factor like population density, travel patterns, virus characteristic. You remember, right? During the corona, how we suffer a lot. Other factors like human behavior, far too many variable for a human to process efficiently. So that's why in number one we call it this is the increasing complexity. Let's dive in the second one. Limitation of physical tools. Traditional physical tools often fall short when dealing with these complex problems. They can be slow, imprecise, and limited in scope. This is the limitation. Consider difference between using and modern computer for a complex calculation. The computer's speed and accuracy are incomparable in the physical world if we want to calculate something. But if we come here in the cyber world, that is solve this limitation. And in the number 3, needs for speed and accuracy. Accuracy is very important. Computers and AI offer on precedented speed, really, and accuracy in the decision making, and wonderful speed. Computers can process vast amount of data, big data, perform complex calculation in the fraction of a second, far outpassing human capability. In the fields like high frequency trading, decision needs to be made microseconds, something only possible with the advanced computer systems. So that's why we need to bring here such a demand. We need some sort of advanced situation. This factor drives our needs for computational solution, pushing us to model our physical world in the digital realm to leverage the power of the computers and AI. Wow. I little bit feel really I need AI and cyber space. So the way I am teaching, trying to transfer such a feeling to you to understand why we need. Okay. I put this slide to emphasize the concept of bridging the physical, real world and cyber world is at the core of the modern problem solving. We have a problem here in the real world. We have some problem, as I mentioned many times. So this bridge allows us to take real world challenges, translate them into the digital model, solve them computationally, and then apply those solutions back in the physical world. Consider development of self-driving cars. This is an example. Physical world. In the physical world, we have road, traffic, signal, other vehicle, pedestrian, and varying weather condition. In the cyber world, we have an AI algorithm process this data, make decision about the steering, acceleration, and braking. So the bridge between bridge process. The sensor on the car captured this physical world's data in the real world. So we have this data, bridge capture, and the AI manage. And then we back, every slide, I try to add something more. Please attention to every slide deeply and with a nice, attention, you will get my point. This repeating has some reason, so please attention. Now, in this slide, I am talking about back to the physical world, from the cyber world back to the physical world. What we are doing? What I am explaining? After learning the AI and big data in the class, you will be a very expert. You can have, only technique is not enough for you work in some big company. Only technique, AI technique, if you can learn from YouTube some technique, AI, machine learning, many type quickly, but nobody teach you deeply. If you learn deeply, then when you go to the company, you will be genius. Okay, you may say, I don't want to go to the company. I want to continue master and PhD. That is also very important. You pay attention to the way of my teaching. So this is very important. So back to the physical world. Let's back to our discussion. These decisions are then implemented in the physical world, controlling the car movement, as I mentioned, for development of the self-driving cars from physical world. We have a road traffic, many. Then bridge is a sensor capture to the cyber world. In the cyber world, AI and big data analyzing, make decisions, accelerating, and then data mining, many techniques, then back to the physical world. These continuous loops between the physical world and cyber world allows and that the self-driving car to navigate complex real-world environment. Wow. It is a powerful example of how we are using the cyber world solution to address physical world challenges. So please attention to this very important point. So let's start by examining the physical world. We need to examine this physical world very well to make us great imagination. This is our tangible reality. We live in this world. When you touch the table, car, building, this is tangible reality. The world we can see, interact directly, this is the physical world. It is complex, often unpredictable, and governed by physical laws. So physical laws, and this is we have in the nature. Okay, let me give you some important point of characteristic of the physical world. Number one is a tangibility. We can directly interact with the object and environment. This is called tangibility. Number two, continuity. Time and space are continuous, not discrete. So number two is continuity. and we have something continuous, time and space. Number 3, which is complexity. Even simple system can have complex behavior due to numerous interacting factors. So complexity is another. Remember, maybe in the exam I ask you, explain about the physical world characteristic. And number 4 is the limitations. We are bound by physical laws like gravity and the speed of light. This is the limitation. Okay, this is the characteristic of the physical world. Understanding these characteristics is the crucial because they form the basic of the challenges we aim to address with the cyber world solution. For example, the complexity of the weather system in the physical world is what makes accurate long-term forecasting too challenging, driving the need for the powerful computation models. Okay, now in the next slide, I'm going to add one more word, near to the physical world. So that is, as you imagine, that is cyber world. When we put together transitions from the physical world, real world, that tangible world, to the cyber world is a crucial process that forms the foundation of our ability to leverage computational power for real world problems. Okay, let's this transition. Let's explain about something about these transitions. Several steps. So number 1, data collection. So in the real world, this transition needs number 1, data collection. Then number 2, that so number 1 is a data collection, and number 2 is we need, because data, when we collect it, when we write in the paper, for example, number of car pass from these roads, we need to digitalize, because cyber worlds only accept the digital data. So number 2 is the digitalization. Then number 3, I'm talking about the several key steps for transition between the physical world to the cyber world. Number 3 is a data structuring. After we digitalizing, then we need to structure it. But we cannot understand very well unless we do step 4, which is model creation. I am talking very basic, which is very useful later on to understand the basic concept of the big data and AI. So let me little bit more explain about these 4 steps. So transitions has a 4 steps. In the first part, data collection. We use various techniques like sensor, cameras, we take a picture. This is the data collection, number 1. And data input system to capture information from physical world. We use the 3D sensor. We use the Kinect. We use the camera. We record the voice. All is a data connection. Sometimes the device help us directly data connected in the digital form. So number 1 and 2 do together. For example, when we record the voice, this is automatically number 1 and 2 do together. But sometimes we draw some painting by hand, but this is the paper. We need to digitalize, but sometimes we take a picture. So directly data collection and data digitalization do together. So data digitalization is a analog information is converted into digital format that computer can process. So analog means manual, not digital information. So this is number 2. Number 3, when we talk about the structuring, the digital data sometimes is we will talk later on structural data. So digital data is organized into format that facilitate efficient processing and analyzing. So structuring, organize to the format that help us later on prepare for modeling. Number 4, in the number 4, model creation, we develop mathematical and computational models that represent physical phenomena. Okay, let me give you one example, which is using the AI and big data. That example, let's say, talk about the smart city system. So I'm going to talk about the smart, these days is very hot topic. When you learn the big data and AI, one example is a smart city. So in a smart city, a physical sensor, step 1, which data collection. Physical sensor connect data on traffic flow, air quality, and energy usage. Then this data in the step 2, data is digitalized and transmitted to the central computers. In the step 3, data is structured into database and time series. And number 4, these models are created to analyze pattern and makes prediction. AI here is play very important part. As you can see here, AI and the big father of the AI is the analytics. History of analytics come back for 405 years ago. I will talk it later. And the end of the analytics come to the AI. And for doing this one, we need modeling. To better capturing the real world, we need not little data, we need more data. So these transitions, which I explained in the 4 steps, allow us to bring complexity of the physical world into a realm where we can apply the power of the computation and AI. So this is very important issue which I try to talk in this slide. In the next slide, I will talk a little bit more about the cyber world, because this one we talk and the conversion and transition I talk, and I want to little bit talk about the cyber world in the next slide. So cyber world is a digital realm where we can manipulate, analyze, and process the data. Which data? The data we've captured from the physical world. It is a space of algorithm, simulation, and computational model. So here, This is the motherland of the algorithm, simulation, and computational model. So let's talk about the some characteristic of cyber world. First, digitality. This is the one characteristic. Everything is presented in a binary code. So can you tell number 2 or several? Please pause the video. We are going to reach to the end of this video. I am worried too much, maybe timey. I will try to keep it like 40-50 minutes. So try to pause and tell me what is the next. Okay? After pausing, okay, answer to me. Okay, let me continue. I suppose that you already paused and answer. So first is the digitality. Second is the speed. Process can occur at incredible speed, limited mainly by hardware capability. And number 3 is the scalability. Solution can be easily scaled up and done. So this scalability is the flexibility of the cyber world. And the fourth one and the last one, but not least one, connectivity. Different systems can be interconnected and share data globally. Wow, these 4 characteristics of cyber world. So in the cyber world, we can perform operation that would be impossible in the physical world. For instance, let me give you some example. When we can run thousands of simulation of a complex system in the fraction of the time it would take for one real world trial. Oh, 1,000 of simulation in a very small part of second for a one world trial. We can analyze pattern in data sets, very big data set for any human, to comprehend. We can create virtual environment to test different sort of scenario without real world risk. Something happen, some assassination happen. So his mind doesn't work if we just use our physical world limitation. But in the cyber world, we can make many sort of scenario to even we don't need to create many place to check those scenario. We can do everything computer. Okay, so understanding the nature of the cyber world is a crucial for appreciating the power and limitation of AI and big data solutions. This is really important. So I'm going to stop the video here. I think is enough for this video. In the next video, I will talk about the second part of the lecture 2 and talk about the benefits of the cyber world. What really those benefits are exactly. That would be helpful to little bit talk more about this slide.